Hello, so student. So this session is for the ICSE class 10. Those who are just going to appear the board exam by next 2 months, right? So I know that you are in a revision phase now. So just follow my sessions, and I am going to give you some technique by which you can do the revisions, and there are few concepts which are taking more time for you. Let's say, for example, Fleming's right hand rule. So in Fleming's right hand rule, if you take like this, so this will be the direction, this will be the motion of the conducting wire, and this will be the direction of the magnetic field, and this will be the direction of the induced current, right? So to remember, you can say that 1, 2, 3, 1, 2, 3, 1 and 2 are input, and the third will be the output. So input, input, output, input, input, output, right? So first input is the relative motion between the the magnets and the conducting wire. The second input is the existing magnetic field, right? So the third, this will be your outcome or output, that is the direction of induced current. So this is about the Fleming's right hand rule. Now the fact is that Fleming's right hand rule, what is the actual background? The electromagnetic law, right? So law of electromagnetic induction. So that is the actual fact, and Fleming's right hand rule is just presenting that law, the output of that law. So what is the Faraday's law of electromagnetic induction? If you have a magnet, let's say it's a north pole, and if you have a conducting wire, so this is a conducting wire, right? So whenever there is a relative motion, like conducting wire can come closer to the magnet, conducting wire can go away from the magnet, or magnet can approaching towards the conducting wire, magnet can go away from the conducting wire. So in all four cases, so you can see there is a relative motion. So this is called relative motions. Now whenever there is a relative motion happen, what change is going to happen? This magnet is having the magnetic field lines, right? So this, these field lines have a range. When this conducting wire is under the range of the field lines, so this field lines is going to expose on this conducting wire. Now, the field lines, one more name we are seeing, the flux. So the flux is actually the field lines. The symbol of flux is phi, and the field lines are magnetic field like B. So phi is B dot A. So this flux is the dot product of magnetic field and the area. So flux is an a set of field lines crossing an area is the magnetic flux. So when this flux is exposing here, so when first it will come in the range of this magnet. Now whenever there is a change happen in the motion between these two, so the flux exposure is going to change on the conducting wire. Now whenever there is a change in flux happen on this conducting wire, there will be an induced EMF impacted on this conducting wire. So this wire will receive an induced EMF, and obviously this EMF is going to induce the current. So induced current is coming from induced EMF. Okay, so an induced EMF is generated due to the change in flux, and the change in flux happened due to the change in the relative motion between these two objects. This is the magnet, this is the conducting wire, where there was initially no source of EMF, but EMF is generated. That's why it's called, law of electromagnetic inductions. So this is a famous law discovered by Faraday. And one more thing is the Lenz's law. So what Lenz is saying, that whenever there is let's say this is a north pole, if north pole is approaching towards this conducting wire or coil, what happened that whenever the flow of current happen, it will flow in such a way that there will be north pole. Whenever a magnet is trying to approach towards this conducting wire, after electromagnetic induction, there will be a north pole here, so that north pole and north pole will repel. So the approaching event is going to oppose by the Lenz's law. So Lenz's law is saying that what is the cause of this flux or EMF happen? The induced current is going to oppose the approach of this magnet toward this conducting, toward this coil, right? So whenever this north pole is approaching, there will be an anti-clockwise current happen, so there will be north pole. Okay, now if this north pole is going away, even that case also there will be change in flux happen, so there will be induced current, and that current will be in the clockwise direction. So if this is the north pole going away, there will be south pole who will just attract this north pole. So if this magnet is trying to approach, there will be north pole for repulsion. If this magnet is going away, there will be south pole for attraction. So this is discovered by Lenz's law. So this is all about your practice. So dear students, you can do the similar way kind of revision, because I know that you are planning for a lot of mock tests in our Chatterjee Academy. We are also conducting mock tests. Yeah, that's very good, but apart from giving mock tests, you have to recap each and every concept of your own way. So the technique I have shown you, this is a recap technology. So for each and every chapter, each and every critical concept, you must go for recap your own way, and that will give you additional confidence before the board exam. So when you are going to give the board, you should have confidence that yes, you can recap the full syllabus in one shot. So in your off time, whenever during your day preparation, spend 10 minutes for physics recap. First you start with one by one chapters, and after few days you can go with 3 chapters at a time. Like I am telling you, electricity has 3 chapters, right? So these 3 chapters you can recap in a single day. You can spend 15 minutes. Now light have 3 chapters. You can recap those 3 chapters in a single day, 15 to 20 minutes. And the mechanics has 3 chapters. You can recap all those 3 in one shot, right? So this way you must recap, and it will give you more confidence for physics preparation. For example, mechanics, you are having the chapter work energy, right? So work is the dot product of force and displacement, right? So you have to remember that work is a scalar quantity, is a dot product of force and displacement. So F is cos theta. So the theta is very crucial. When theta is 90, cos theta 0, work will be 0. When theta is 180, that means work will be negative, because cos 180 is minus 1. So these things you have to recap. Same for optics, in refraction, what happened, that during the refraction the velocity of light got changed in different medium, and velocity is directly proportional to the wavelength of the light. So when velocity is changed, wavelength also getting changed in place of refraction. So these things you can go and revise and follow my sessions. In the next revision session, I will show you about the short practice on optics. Okay, so please go like that, and it is going to really help you for the physics preparation. Okay, all the best for your coming exam. Okay, thanks for watching the session.